In current electricity, Kirchhoff's laws are very important. Using Ohm's law, we can find the current through very simple circuits. For complex and complicated circuits, we have to depend on Kirchhoff's rules. There are two rules, first rule and second rule. First rule is otherwise known as current rule or junction rule. It is applicable for a junction. Here there is a junction where many currents are meeting. Then for applying the Kirchhoff's law, we have to take a proper sign convention. First rule states that algebraic sum of currents meeting at a junction is 0. When we use the word algebraic, we have to give proper sign convention. Here the sign convention is the current coming towards the junction is taken as positive. Current going away from the junction is taken as negative. So you can see here current I1 is coming towards the junction, that is understood from this arrow. Arrow is directed towards the junction. So I1 is coming towards the junction, so positive plus I1. I2 is also coming towards the junction, so plus I2. But see the arrow here outward. So current is going away from the junction, so minus I3. I4 is again coming towards the junction, so plus I4. Then I5 is going away from the junction, so minus I5. I6 also going away from the junction, so minus I6 is equal to 0. Algebraic sum of currents meeting at a junction in a circuit is 0. Now let us take some examples. I1 is, let it be 0.2 ampere. I2, let it be 0.5 ampere. I3, let it be 0.3 ampere. I4, let it be 0.5 ampere. I5, let it be 0.3 ampere. Now I6 is not, suppose I6 is not known, we can find out what is I6. So we can substitute in this. I1 0.2 plus I2 0.5, I3 0.3, I4 0.5, I5 0.3. So we have to find I6. Now I6 you take to the other side, then 0.2, 0.5, so 0.7. Next 0.3, so 0.7 minus 0.3 is 0.4. 0.4 plus 0.5, 0.9. 0.9 minus 0.3, so it is 0.6. Minus I3 is I6 minus I6 is equal to 0. So I6 is 0.6 ampere. Kirchhoff's second rule, otherwise known as voltage rule or loop rule. First let us see the statement. Kirchhoff's second rule states that algebraic sum of the product of current and resistance in a closed circuit is equal to algebraic sum of the EMF. That's the statement. When we use the word algebraic sum, we have to use proper sign convention. Let us see the sign convention. If the direction of the current is in the direction of the loop, it is to be positive. For example, here current is along this direction, this arrow mark. But the loop can be A to B or B to A. If the direction of the current is in the direction of the loop, it is to be positive. So here current is I, resistance is R. So I into R, it is positive. So to make it little more clear, you consider you are walking from A to B. Then direction of the current is in the direction of your walking, it is positive. Here B to A, here it is A to B, here B to A, see the arrow mark, current is in that direction, but you are moving from B to A, going from B to A, now it is negative. So here loop is B to A, so negative. So the direction of the current is opposite to the direction of the loop. Here EMF, the rule for EMF, a cell will be sending current from the positive terminal to the negative terminal. This is the direction of the current. Suppose you are going from A to B, it is to be taken positive. So V is equal to plus psi. So it is positive. V is equal to plus psi. So positive. V is equal to positive, then psi. Here B to A, then V is equal to negative psi. So in the case of EMF, that's the rule. So cell will be sending current from the positive terminal to the negative terminal. When you go from B to A, it is opposite. So that is why it's a negative. Let's make this idea clear with an example. Kirchhoff's second rule is otherwise known as voltage rule or loop rule. Now let us apply Kirchhoff's second rule to this circuit. Kirchhoff's second rule is applicable for a closed loop. Current in the circuit should be steady. Then only we can apply Kirchhoff's second rule. E A C E. Let us apply Kirchhoff's second rule for this closed loop. Here current is I1, resistance is R1. This arrow is giving the direction of the current. So the direction of the loop is in this direction. Direction of the current is also in the same direction, or imagine you are walking from here to here, E to A. Direction of the current is same as you are walking, so positive. So I1 R1. Then here current is I2, resistance is R2. So direction of the current is same as you are walking, or it is in the direction of the loop. So plus I2 R2. Here direction of the current is in the direction of the loop. So again positive, plus I3 R3. Algebraic sum of the product of resistance and current is equal to algebraic sum of the EMF. Only one EMF is there in this closed loop, closed circuit. So you are moving, or loop is in this direction. So battery is sending current, or cell is sending the current from positive to negative. So it is positive. EMF of the cell is psi. So that is a Kirchhoff's second rule. Algebraic sum of the product of resistance and current is equal to the algebraic sum of the EMF. So instead of EACE, you consider the loop in the opposite direction. Instead of EACE, ECAE, ECAE. So now every sign will change. Here, loop is in this direction, current is in. So see the direction of the current I1 in this direction. Now it is loop is in this direction, ECAE. So it will be minus I1R1. Here, loop is in this direction, current is in opposite to the direction of the loop. So minus I2R2 minus I3R3 is equal to now minus psi, because loop is in this direction, EMF is sending current in this direction. Current is always from the positive terminal to the negative terminal, but loop is along this direction, ECAE. So that's why it is negative. So I have applied Kirchhoff's second law for this closed circuit or closed loop. Now I will apply Kirchhoff's second rule for this closed loop. Direction of the loop can be in this direction or opposite. First let us see ABCA. Then here current is I4, resistance is R4. So this is the direction of the current. Loop is in this direction, ABCA. So direction of the current is in the same direction as the loop, direction of the loop. So positive. So here current is I4, resistance is R4. Here current is I5, resistance is R5. Then see the arrow, it is in the same direction as the loop. So plus I5 R5. But here direction of the current is opposite to your movement. So current is from A to C, but you are going from C to A. This is the direction of the loop. So minus I2 R2 is equal to algebraic sum of the product of resistance and current is equal to the algebraic sum of the EMF. So in this closed loop there is no cell, so EMF is 0. So algebraic sum of the product of resistance and current is equal to the algebraic sum of the EMF. Instead of ABCA, suppose you are moving in this direction, ACBA, opposite. So every sign will change. Now instead of plus I4 R4, it will be minus I4 R4, because you are moving along ACBA. So you are moving from B to A, but the current is from A to B. So that's why minus. Current is opposite to the loop, direction of the loop. Similarly here, in this also you are moving from C to B, but the current is from B to C. So it is minus, instead of plus now it will be minus I5 R5. Then here current is from A to C, so your movement is also from A to C, so plus. So instead of minus now it will be plus I2 R2. Then since there is no EMF in this loop, it is 0. So that is what is Kirchhoff's second rule. Algebraic sum of the product of resistance and current is equal to the algebraic sum of the EMF.